A rectangle with integer side lengths is divided into 4 smaller rectangles as shown. The perimeters of the largest and smallest of these smaller rectangles are 28 and 12 centimeters. Which of the following is a possible area of the original rectangle? So first we want to find the perimeter of the original rectangle, which we can do by adding 28 and 12 centimeters, which gives us 40. Now, because 40 has given us the entire perimeter, because we only want half of it, we want to divide 40 by 2, which is equal to 20. Now, when I did this, the first noticeable pair was 12 and 8, which is answer D, 96 centimeters squared. But if you wanted to prove that it was actually 12 and 8, we could write out all of the possible combinations. So 19 and 1, 18 and 2, 17 and 3, and so forth. But because there's no other noticeable number here, the answer would be D, 96 centimeters squared.
Very nice. So you worked out the perimeter of the larger rectangle, got it to equal to 20 for the width and the length, and then out of those numbers that make up 20, only 12 and 8 make can kind of multiply to give you some sort of answer. And you can check that by doing all the pairs possible. But 12 and 8 they obviously are 98, 96. But could you explain how you worked out the perimeter of the larger rectangle from the perimeters of the 2 smaller rectangles? So here we've got 2 of the smaller rectangles of 28 and 12. How do you figure out the larger rectangle?
Yeah, so if you want to move the length of the smaller rectangle down to the bottom, okay, and the width of the larger rectangle over to the right,
okay,
yep. These are the same lengths, so because it's a rectangle. So we know that when we add up 2 of these sides, they would be the same. Now, if you move the width of the smaller rectangle over to the left, and the length of the larger rectangle over to the top, this forms our original rectangle because they're the same lengths, meaning that they're just going to be the lengths and the widths are going to be the same.
So they actually just turn out to be exactly the same, although it doesn't look like it. But essentially, this line there, these lines, well, they're actually the same.
Yeah.
They just been moved across. They've actually just been moved across. Very nice. Actually, I'll fill in the last one.